Hello everyone, my name is Paul, and today I'm gonna do a presentation about one of my interesting projects in Deakin University. So this project right here is the final project in the unit SIT 210 Embedded System Development in Deakin University. And the requirement is that we need to construct a robotics or IoT solutions that is able to tackle a real world problems. Yep. And in this presentation videos, I'm gonna do a tutorials of basically that's gonna include the components, the sensor that I was using in the project, and the code, and also the web server and everything that is behind the project. Everything that you need to know in order to construct the exact project like mine from the start to the final phrases. All right, so let's get to the point. So my project is called the WindWise project, and the problem that my project is trying to address is to optimize wind power. We know that windmills play an important role in converting wind power to rational energies, and windmills are placed like everywhere around the world, and they also placed on different terrains, which they could be placed on mountains, could be placed over the oceans, or on a farm or any open area. So the problem is that how can no, not actually the problem, but the idea is that how can we optimize the wind power? How can we convert more wind power to rational energies? So my solution is that we simply just make the windmill able to spin toward the wind, and that's it. So that's mean when once you place the windmill, like instead of the fixed windmill, its fixed position. Like before, we have windmill placed. When this was constructed, it's gonna face the west direction, which means it will spin when the wind is coming from the west directly at the windmill. But what if one day the wind is coming from opposite or like any other direction, like from the north or the east, or yeah, any different directions? Then my idea is to make the windmill able to adjust itself, able to spin itself toward the wind directions. That's mean if the wind's coming from the north, then the windmill's able to detect that wind is coming from the north. It's gonna spin toward the north. That's it. Um, yeah, so that's the idea, and now we're gonna go through the schematics as well as the sensors and components that are used in this project. So let's go one by one. Okay. So the first thing right here, we have a Raspberry Pi. This is a Raspberry Pi 4 Model B, and it is the main processor of the windmill. Well, I chose Raspberry Pi because it is able to handle complex computations, and uh, it got built in Wi-Fi, so that's the reason I chose it. But you can go with other options as well, as long as they can go online, and they are like their CPU is decent enough to calculate some basic calculations, and also they have to be able to read data from the sensors. So that's it. So yep, I have a Raspberry Pi. In here I have one. This right here. As you can see, this is a potentiometers. So this is a potentiometer, and what a potentiometer do is that it tells you the exact angle that the sensor is currently at. So I use this potentiometers to detect the wind directions. Um, if it sounds kind of like uh, complicated for you at the moment, then we're gonna see it later in the demo videos. But right now, let's just understand that this potentiometers right here is used to analyze the wind direction to detect where the wind well, which direction is the wind coming from? Yes, that is the purpose of the potentiometers. And right on the left side, right here, we have a servo. I'm using the servo to spin the windmill, to spin the body of the windmill, to adjust itself to the corresponding wind direction. And these two gonna collaborate with each other. So which mean this the potential meters right here gonna analyze the wind directions, where the wind is coming from, and then the Raspberry Pi gonna handle. It's gonna mm, it's gonna read the values that's coming from the potential meters, and then it's gonna adjust the angle of the servo right here to spin the windmill to the correct direction where the wind direction is coming from. That's it. And in here I have a fan, it's more like a cooler fan to cool down the Raspberry Pi in case it gets too hot. That's it. And on this side, let's get to this upper part right here first. And this right here is an Arduino Nano, and the this Arduino Nano is it's read the voltage that the windmill is producing. It's read the current that the windmill is producing. It's like the nano here basically it use a current sensor to read how much current is the windmill currently producing, to see like is it effective, and also to plot a diagram of the current flow in the windmill. So yep, again, all this Arduino Nano right here doing is that it uses a current sensor to read data that is generated from the windmill coming from the DC motor. So right here we're gonna have the blades of the windmill right on the top of the DC motor, and then whenever the blades start spinning, the DC motor gonna generate current. That's gonna read through this current sensor right here by the Arduino Nano, and then this is the important part. The Arduino Nano gonna pass the value of the sensor to the Raspberry Pi using serial communication. So serial communication is basically USB transmissions right here. So there's gonna be a USB cable that is connected between the Raspberry Pi to the Arduino Nano, and the Arduino Nano gonna read data from the current sensor, and then it's gonna pass the data to the Raspberry Pi using serial communications. And also you can see an extra batteries right here, which are used to like, because windmills gonna convert wind power into rational energies. So in here I use the windmills that gonna convert the wind into energies that will be used to charge the battery. So this battery right here is gonna be charged up by the windmill, by the DC motor right here. So that's it of the main components in here. Let's go through everything once again. So we have the Raspberry Pi that's going to use the potentiometers to analyze the wind direction, and then it's going to control the servo to spin the body of the windmill to the corresponding direction. The fan is going to cool down the Raspberry Pi in case it gets too hot. And then the Raspberry Pi is connected to an Arduino Nano through a serial communication. The Arduino Nano play an important role in reading the current that is generated by the windmill, and then passing the value of the current to the Raspberry Pi through serial communication. The reason that I chose serial communication is that the value is going to be transferred at a decent rate, and then uh, well, actually you can just connect the current sensor with the to the Raspberry Pi, but I choose the current sensor to be different, to be like separate from the Raspberry Pi, but instead connect to the Arduino Nano, because at some point you might want to replace like any part of the windmills, and it's good to have them all separated, not to relate on each other. So yeah, in case one breakdown, you can just replace them easily. And also, using cable is better to transmit the data, because cables, like it's harder than normal jumper wires, and it can go as long as we can. So which means we can place the Raspberry Pi on the ground, or where it is approachable for us, and then the Arduino Nano is going to sit on the top of the windmill, and they're all going to be connected with a serial cable, a USB cable. And you might wondering, what is it down right here? So down there, I got a. This can be understand as like a terminal. Here, this whole thing right here, the particle argon and the LCD right here. This is the terminal that's gonna inform you how much power is the current windmill is generating. That's it. So a good thing is that this thing is run wirelessly, and it's running on a external batteries. So this is a particle argon. The particle argon gonna read the data from the Raspberry Pi. The Raspberry Pi gonna publish the data on a MQTT server, MQTT broker, and then the particle argon gonna retrieve the data. It's subscribed to the same broker. It's retrieved the data from the MQTT broker, and then it's going to display the data on the LCD screen right here. It's going to display the current windmill, and the how much power is the windmill generating. That's it. We're gonna see how this thing works later in the demos videos for a better understanding. But currently, that's it. All the sensor and all the components, as well as the processor that I'm using in this project. So right now we're gonna head to the code snippet, and everything that we need to know behind the the windmill project. Just before we get to the code, I wanna specify that this project is run on a Node-RED server. I use a Node-RED server to to create a dashboard that it is accessible from the website. So basically, you can adjust everything on the website. You can manually control the direction of the windmill, or let it go on auto mode, which means the windmill's gonna control itself to face the wind direction by itself. And yep, so it's operated through a Node-RED server, and this is what the Node-RED is looking like. Well, we're gonna go through the Node-RED later, because the main Node-RED is actually inside the Raspberry Pi. I am doing this presentation on a computer, but I'm just showing you the idea of I'm using Node-RED to power the whole no to operate the whole project. So yeah, we're gonna go through the Node-RED thingies and the dashboard later, once we boot up the Raspberry Pi. Currently, I'm just showing you what's going on with the Node-RED right here. Yep, in the code right here, we have two main functions. It's the auto rotation mode and the manual rotation mode. So for the auto rotation mode, so so okay, let's go by one. We have this whole part, like so in this auto rotation mode, what it's do is that it read data from the potential meters, and then control the servo to its corresponding this corresponding direction, and then the servo's gonna be controlled by a like what is called an angle. So you're gonna need an angle to pass into the servo to have it spin as the correct direction. So that angle value is gonna publish into an MQTT server. So there are two values that's gonna be published to the MQTT server. One is the angle of the current windmill. Two, the second one is the current, which means the power that the windmill is generating. Those two values gonna be published into the MQTT broker. And the MQTT broker that I use is the Hive MQTT. Right, so we have this whole code right here. This code right here, as you can see, that code is to establish the connection between the Raspberry Pi to the MQTT server. And then right here, I put it on the while true loop, because this is auto mode, this is automatically rotation mode, which means it will be put in a while true loop. It's going to be put in an infinite loop that's going to spin itself toward the wind direction. And so it's gonna analyze the wind direction by using the rotary angle to read the current angle. And that's what's happening in this file right here. Rotary angle, yep, right here. Rotary angle to read the current value right here. As you can see, the value equals sensor dot value. This code right here is gonna read the value, which is the current angle that the potentiometer is currently at. The range of the range of the potentiometer is from 0 to 999. And I have this extra try and except to check if the range is like outside of the minimal or upper upper yeah, if the range is outside of the range that it's supposed to be from 0 to 999, then that's a false case. So yeah, again, this potential, this rotary, and this is the rotary angle code that's gonna read the value from the rotary sensor and get back to our auto rotation mode. So here we after we run the rotary angle sensor reading code, we're gonna have the current angle that the rotary sensor is currently at. And then I make a function to map the angle of the rotary sensor to the to a degree, an angle from 0 to 180, because the potential meters, its return value from 0 to 999, and the servo need values from 0 to 180 corresponding to the servo to the angle that it's gonna be spinning. So I retrieve the value from the potential meters from 0 to 999, and then I map the value to 0 to 180 and then I'm going to use that same value to control the servo. So let's take an example. If the value returned from the potential meter is around 500, then that value 500 gonna go through the mapping functions, and it's gonna result in the from from 0 to 999. 500 is the middle point, right? So convert it to the scale of 0 to 180, then 90 will be the middle point. So that's mean the value 500 in the mapping range functions from 0 to 180, it's gonna be 90. So that's an example of the map range functions, how it's working. And the function is right here. You can see the code. Basically, it's take the upper border and then the lower border, and then it's scale the upper border with the lower border to return the corresponding value. Yep, and yeah, and so once after it has convert the potential meters value to the corresponding servo angle, then it's gonna see if the it's gonna see if the current angle is different from the new angle, which this kind of complicated, but it's mean like if the windmill is currently at 90 degrees, right, and then there's something change in the wind, making the potential meters convert the value to the servo, and it's result in say 100 degrees, 100 degree, which mean the new value is 100 and the old value is 90. So they are different. And this means that the wind has changed direction. So that's what's happening in the code right here. So this code right here is it's so if the windmill change to a new direction, change to a new angle, that is that is different from the current angle that is currently at, then it's gonna send a notification to my phone through a Telegram service. I use Telegram service because they're easier to create bots and easy to link to the project. But you can use any other platform like Gmails or WhatsApp or everything like that. Just because I'm familiar with Telegram. Right. So this code right here, you can see, is that if the new angle, which means the new angle that is read from the potential meters, if the new angle is different from the one angle that the windmill is currently at, and it's different in 5 degrees. If the angle is different, then a multi-threading process will start to send the notification to my phone. But I have something with this multi-threading is that I create a timer inside the multi-threading, which mean I'm gonna take an example for you to easy understand because this is kind of hard to describe. So which mean if the windmill is facing at 45 degrees, and then a second later it's analyzed to the wind has come from other directions, say 90 degrees, then the previous angle is 45, the new angle is 80s, then it's going to spin toward the 80s angle, and then it kind of sit there for a period of time. Right here I'm setting it to be 10 second. It's going to be sitting there in 10 second, and then if in the next 10 second it does not move to a new angle, which means the wind is stable and it's coming from that direction, that 80 degree direction, the wind does not move, does not varies to other direction anymore, then it's going to send a notification to my phone in less than 10 seconds. But the thing is, if the windmill moves to the 80 degrees direction, and then just 2 seconds later it's moved to another direction, like it's moved to 90 degree, or it moved back to 45 degree, then the notification thread will be canceled, and it's gonna start the thread again once the position of the windmill is stable. That's mean the thread is gonna go like this. So the windmill's at 35 degree, it's spin to 80 degrees, and then there's gonna be a timer thread that start counting like 1, 2, 3, and then suddenly the winds start changing direction to 90 degree. It's gonna change to 90 degree, and then the timer gonna be reset. It's gonna be reset like 1, 2, 3, 4, gonna be reset again. And if the windmill is sitting stable at 90 degree for a long time, then the timer is going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At the exact time, 10 second, it's going to send a message to my phone. That's it how it's work. And if less than 10 second, the windmill change direction, then the timer is going to be canceled and start all over again. Yep. So that's it for the code right here. And down here, this code is this code is to control the servo to change the windmill direction to its corresponding direction. Let's see the main thing. Let's go through one by one. This one, servo control auto change angle. That is a function in this code right here. Auto change angle right here. Right. So the this function takes in two parameters: current angle, and new angle. And then all the code right here is that if the new angle is larger than the current angle, then it's gonna spin to the left to the right side, and then if it's smaller than the new if smaller than the current angle, then it's gonna spin to the right side. Well, all in all, this whole it's gonna control the pulse width of the servo, but all in all, this whole process is to analyze the movement of the potential meters and then control the servo accordingly. See, if the angle is the same, then it's gonna just put in a slate function, and if the angle is different, then it's gonna spin to the different direction. Right. So that's it for the auto control mode. And then right here, I publish the current angle value to the MQTT server. Right. So that's it for the auto control, auto rotation mode. Right here, I'm gonna show you what's going on with the Telegram service. So I have a config. I got a JSON file that's going to store the credentials of the Telegram, including the token and the ID, or those are like private informations of the Telegram bot. But right here, I'm going to load the JSON file and then assign the value to variables, and then it's going to use request to send a text message to the Telegram chat. So how it's going, it's that we create a bot on Telegram, and then we retrieve the token from the bot, and then we use that token to put it in this code right here. To here you can see the token is right here, or you can put in the .json file. It's gonna retrieve the code, and then it's gonna send a message. You can of course customize the message to your own preference. Right here I have the message is windmill number one has just changed its direction, but you can change it to anything that it can. You can change it to an informative message like the windmill has changed the direction to the north side, to the west side, or what its current angle is at. That's it. Right here is the timer multi-threading. So the timer multi-threading, it's no, this is just a timer function. The timer multi-threading is it's back in here. So a little bit about it is that I have a stop event right here. This stop event is like a flag in the timer. So before I told you that if the timer is less than 10 seconds, then and then the windmill change to a new direction, then it's gonna reset the timer. That is where uh, this stop event is gonna set. So so the stop event is that if the stop event is set, then the timer will be stopped and starting all over again. Yeah, just like that. And let's see what else. What else we got? We got we got this right here is the manual rotation mode. The manual rotation mode has nothing much at all because the process is uh, like this process is on Node-RED. So I'm gonna show you later once I boot up Raspberry Pi and Node-RED. And well, let's briefly go through the manual function. Is that we this is the function right here. Yep, and we just put in the new angle as the parameters, and then the servo's gonna adjust itself to that angle. And right here is the code for the uh, the Arduino Nano right here, as I told you before, because we have go through all the code file in the Raspberry Pi. Now we're gonna go through the code in the Arduino Nano. So my bad. So here we got a library, the library that we need to import to include the library, and then this library is the name of the sensor, and then we just we in the setup function we initialize the terminal or the serial because all of the information is gonna pass through the serial. So here serial will begin, and then the sensor will be calibrated, and then the sensor will start reading the current DC value and then print it to the serial. And there's one more thing. This is the growth current sensor right here. So this file right here is the serial communication between the Raspberry Pi and the Arduino Nano. So you see right here, they all connect through a USB cable right here between the Raspberry Pi and the Arduino Nano. So this file right here is gonna handle the connection. Yeah. So this whole part is to read the JSON file, including the credentials of the MQTT server, because the value of the current value, which means the power is generated from the windmill, will also be published to the MQTT server. So we have this code right here is to connect to the MQTT and then to publish the message to the MQTT server. And the uh, the important thing is right here. Here you can see we first thing is we need to import serial. Right here we need to I can't zoom in. We need to import the serial library in order to allow us to read from the Arduino Nano serial output from the Raspberry Pi. And right here, we need to specify the port that the Arduino Nano is connected to, and then serial. It's serial here, right here. You see, serial begin at 9600. So right here, back here. So back here, we need to initialize the value is 9600 as well, and timeout to see just to keep tracking of the connection. And then we need to reset the input buffer. So right here, if there's anything exists in this serial communication, and then this line of code right here is the line of code that reads the value from the serial output of the Arduino Nano, which means the current value is going to be assigned to the serial read. Serial read is the code to read the serial output, and then we decode it to a format to that's readable, and then we strip all the spaces. And yep, this code right here is the code that read values from the Arduino Nano that is currently measuring the DC current, the DC, like how much the power the windmill is generating, and it is put in a infinite loop so that the values keep being read as well as the from the Arduino Nano. And then another code right here is that we're gonna publish the current value to the MQTT broker. Yep. So that's all. That is basically everything that's happening in the code. And now I'm gonna migrate to the. I'm gonna boot up the Raspberry Pi, and then I'm gonna go through a short demo videos and show you what's going on with the Node-RED server.